assembly. So, to the new people here, welcome. We are the weird ones. To the old-timer, welcome back. Exactly a year ago in Bogota, we had DEF CON, and the AW presence there was a small room of 20 people in the basement into a self-led session. That's what the organizers give you when they think what you're doing is not actually make sense. And we probably had the weirdest content out there. While everybody else was talking about MEV and ERC 4337, we were discussing digital physics systems that can accommodate biological and non-biological life forms. It was weird. And then here we are, a year later, over the next 2-3 hours, about 500 to 600 people should be trickling in. So it's super exciting to grow an order of magnitude. I thought my talk would have to be an order of magnitude more serious than what I did last year. So I did the opposite thing instead, and I made my talk an order of magnitude more crazy. Okay, cool. So, some people on Twitter make fun of this community for writing stuff that sounds completely crazy and then patting themselves on the back for putting tic-tac-toe on chain. Because the chasm between the concept and the ideas and the actual implementation today is almost comical. And it reminds me of this newsletter called the Extropy Institute. It was one of the first very popular transhumanist newsletter. It's quite controversial. But one thing that is interesting with them is every single time they would see some either deep kind of affordance of the universe or truth about it, it's really hard to unsee it. So at that time, if you go on that newsletter in the 1970s, back when the computers are only really getting started, they're already talking about smart contracts, terrorist future markets, how to make sure that, realizing that biological death is actually just a bug and you can freeze yourself to live forever. And it's kind of interesting because when you take an affordance or an ability and you take it sufficiently seriously, you can't unsee it, even if it's not there yet. And I think that there is something very, very suspicious going on with blockchains and cryptography right now. Myself and a bunch of folks here are really puzzled by this new kind of computer we're building because this new kind of substrate that has been emerging. And there's a sense that there is something really powerful going on here. A lot of folks are blockchain is a solution looking for a problem. I'm not going to preach to the choir here. The people in this room probably think there is actually something we can do with it. But I think it's kind of a general statement about things we don't understand yet. If there's something out there that pops up and you don't have a good understanding or narrative around what the affordances are, it's really easy to look at it pessimistically and be not useful. It can be like that economist that said that the internet would have as much impact on the economy as the fax machine. And I think it was a fair thing to say at the time. It was really the World Wide Web was not a thing. The internet was mostly the ability to send packets from West USA to East USA. So it was fair at the time. So if we think a little bit about what do blockchains actually do? What does cryptography actually do here for us? And if we look at this, if we figure out some affordance and we take it seriously enough, I think something very much like the Extropian newsletter starts happening, where you get the people to get together and make start looking at if we take this seriously, we have to stop everything we're doing. We just have to do something else. And a way to kind of talk a little bit about blockchains today and what they do. There's many lenses to look at it. There's this one lens that I got from Albert Nee that I think is really useful. Is the idea of a commitment, or looking at it from the perspective of the lens of commitments. So a commitment is said to be credible if myself and others can be convinced this commitment will be honored, right? So if someone texts me on Discord and tell me they can teach me how to make $50,000 in one day, this is not a credible commitment. And that's why I'm not going to act on it. But the reason I pay my taxes is because the government makes a very credible commitment that it will fine me if I don't. And there are lots of mechanisms out there to create commitments. But one that is quite interesting is cryptography and blockchains. So I think that blockchains drive the cost of making very, very strong and credible commitments down. So it's possible for anyone today to put a smart contract on Ethereum or a Bitcoin script on Bitcoin and say like, hey, if you send me some money and then someone else after you sends me some money, you will get part of that money. And you can make the strongest possible commitment to a Ponzi scheme. And that's really interesting because the cost of doing this moves from like building an international organizations that like runs this like very large level scams to, oh, someone can just put some code out there and we know he will execute that way. So, and the proof is in the pudding. Like, why do we live billions of dollars in a piece of code that doesn't have human oversight? Or get really scared when people try to deploy what looks like silly little code, but it is actually like a very strong prediction market. There was like big scare a few years ago about prediction markets because they're credible, right? And if we look at, let's look at every single thing a blockchain gives us, and then after each statement, I want all of you to like contemplate, like, does that remind you of something? So the first thing is a blockchain allows you to create rules that make credible commitments that they will remain consistent tomorrow. They will still be the same. They create state. So for the non-programmers amongst us, state is just like, if you have a counter on the internet that anyone can increment, state is the number that is on the counter. So a blockchain can create state that makes a credible commitment to be there tomorrow. It makes credible commitments that to let anyone or anything, humans or machines alike, to plug into the one true core stack and join the symphony of state and execution. And it leverages math itself, the ultimate portable rule set, to define things like information asymmetries and create guarantees around execution. So if you look at this and we like meditate on the affordances, it's very suspicious, once again. This was me this morning at 5 a.m. I woke up to redo all my talk. I was like, what's going on here? Because if we meditate on the affordances and on the abilities given by something like Ethereum, I think it's really hard to unsee the parallel with something like physics. That's, by the way, while like some of you in personal conversations, I've been talking about digital physics for the last like year and a half. And it's not some fancy words for game rules. It's a reminder to take seriously the power of these rules and the power of these commitments. And I think that we have very much trivialized this, especially this group. You know, as we always do with engineering, we built a nice programming language, I mean, not so nice programming language around it. But the fact remains that we have the ability to carve physics in cyberspace with cryptography and smart contracts. Okay, so what happens if we take this seriously, right? And it reminds me of this quote from Carl Sagan, that goes like, hey, if you wish to make an apple pie from scratch, you must first invent the universe. And the reason this is pretty funny is because we actually did that. So first, we took the internet, which is one of the most bonkers thing out there, but we won't talk about it. Then we took crypto economics, which is a not very scientific, arcane way of thinking about how to get people to agree on something when money is at play. Then we labeled some like moon math on top of it. And we think deeply about the affordances and we instantiate the universe. And the first thing we did with it is we put a bank inside it and we forgot about the universe in the first place. And I mean, it's pretty dope that we can do that. But it's like being fish in the water once again. Like, what is the thing we did in the first place? And it reminds me about an episode of Rick and Morty where Rick has a car with a battery, and the way he gets the battery filled up is he creates an entire universe where people in it just like steps up and down to generate electricity. And then these people create another mini universe where they do exactly the same thing. That's layer 2s. They just like recursively create universes. And we forgot that the universe was created in the first place. Blockchains can't help but instantiate these universes, these autonomous worlds. You can kind of talk about them however you want. But it's still hardware. And that's where like it gets really interesting, because if you frame something as a general computer, building the hardware is only half of the battle. And the reason, of course, Ethereum and Bitcoins and all of these, and even cryptography itself, they're not physical hardware. But the reason I say hardware is because their growth is pretty predictable, and they're meant to be as general as possible. Nick Szabo wrote an article 25 years ago about the God protocol, and he imagines this mutually trusted virtual computer that people can talk to. And that's, of course, protocols like Ethereum are not there yet. This is kind of like the limit case of what these systems will be. But they're very much still hardware, even if they're not physical. And it's interesting to look at the history of graphics card. To think about this. So graphics card got started as a way to accelerate very specific kind of graphics programming. And it took, I think, 5 or 6 years before some scientists were like, hey, we can run partial differential equations on these things. And it's pretty damn fast. And then, you got the AI craze and the Bitcoin mining craze and all of that. And turns out the graphics cards just wanted to let them to multiply matrices, Like the self-actualization of a graphics card is to generate cat girl's picture on the Mid-Journey Discord. This is like when you reach Nibbana as a graphics card. This is when you do what you were truly born to do. And I think there's something very similar going on here. And that's where you folks come in. The responsibility you have is to figure out and narrativize what the hardware is for. Because if we have a universe instantiating hardware but no good narratives or application around it, it will remain specialized in the way it is today. And it's actually pretty interesting to look at how fast we went to computer being seen as tools of control from the government, where people were really scared of them, to tools of personal revolution. So between IBM mainframes and the mother of all demo by Doug and Glibert. So if you don't know about this is another crazy thing, where this person, Doug, and a bunch of his friends went in front of a room of people and showed them for the first time video conferencing, a mouse, a text editor, like computers being used by a single person in real time. Like all the people that were at that conference, that demo, they were mostly military people, thought that was computers. And, computers as an operator, you go to the operator, you give them a program, you come back in the afternoon, you get your results. And then Doug and Glibert shows them this thing. And there's no difference in the hardware between this and that. Like they added some fancy input-output methods on top, and they rewrote all the software. But it's fundamentally the same thing. It's based on the same scaling laws, the fact that hardware gets better. What mattered, what changed there is the understanding and the narrative around what the hardware can do. And then more and more people came in and turned the computer into what it is today, which is a tool of personal revolution. So on the left is Stuart Brand. Stuart Brand was the editor of the Whole Earth Catalog. You might know about the Whole Earth Catalog from Steve Jobs' story. He was really inspired by the Whole Earth Catalog. And the premise of the Whole Earth Catalog was access to tools, letting people use tools for themselves and not rely on companies or governments in order to do things. On the right is Alan Kay. So fun fact, the computer on the left of Alan Kay is a Xerox Alto. Xerox Alto, at that time, adjusted for inflation, cost $150,000. Literally nobody in the world could buy a Xerox Alto. And then they knew that the hardware would get better. They just thought, the thing that is going to be a blocker now is not getting the chips to be faster, because that's going to happen anyway. It's to understand and create a narrative around what the computer is for. So they put the labs together, they spent millions building their own hardware, and then they invented the graphical user interface, Ethernet, the laser printer, object-oriented programming. And people thought they were really insane. The company that was funding this lab, Xerox, they only took one invention out of that, the laser printer, and everything else just got kind of like gifted to the rest of the computing industry. Steve Jobs and Andy Hertzfeld famously went there, saw the GUI, and then built the Mac because they thought it was too cool to leave it in the lab. So what I'm trying to say is, don't worry about the hardware not being good right now. Like, it's okay if we're kind of like, you have I don't know who instantiated or what instantiated this universe, but I suspect that at some point they were in the room and arguing about like, yeah, but this type of quarks is faster than that type of quarks. And some people were coming in and be like, no, why are we doing this? We should do that. But like, we can do this. But at the end of the day, we have to remind ourselves, like, we have a universe creating technology. It's really important to kind of like take seriously the big picture and not be stuck into quark engineering the whole time, because the quarks will get better. With physical hardware, we will keep turning sand into chips, and the chips will get better, and we will make exponentially more chips over time. Similarly for us, we will turn ETH research, Vitalik's blog post, and people who like Rust too much into bigger blocks. This will happen. You don't have to worry about it. Gas is going to go to zero or to infinity, depending on how you look at it. But the thing that is much more uncertain is whether we will really understand what the hardware will do and how it will be understood. This is where kind of like the really step function difference can come in for this industry, I think. Because we built a computer we don't understand. If this were like a 1980s sci-fi novel, we'd be building a decentralized banking system, which also happened to be the perfect environment for new digital life forms. Like little bugs molded in the physics of liquidity pool, collateralized debt positions, and speculative bubbles. That's, by the way, what I think MEV is. It's just the mosquitoes of our new universe. We kind of like have to learn to deal with them. So the way we fail here, because that's like an interesting way to look at it, is like, how do we still fail? And the way we still fail is if we commit a failure of the imagination. I'm actually way more scared about committing a failure of the imagination than committing a failure of engineering. There's a playbook for making computers better. And everybody's like so worried about UX. Like, there is a playbook on how to make this better. Like, we fail if we don't know what the computer is for. Yeah, in my notes, I wrote it down as like, you built a computer that can't help but instantiate universes, yet you fail to understand it. That would be very ironic. So what if you took this seriously? So the next 2 days are meant to be a little bit insane and chaotic and have kind of like wild ideas going around. So I'll give a framing. There's this book I really like called Permutation City. And there's many things that happen in Permutation City, but one of the main plot line is that humans create a digital universe called a TVC, which can house humanity forever. By self-executing inside the universe. There is no way to stop the TVC. And after they get into the TVC, there's like a weird an alternative digital life form that emerges from the chaos called the Lambertians. And turns out, unsurprisingly, that the Lambertians understand the TVC better than the humans. And at some point, their total intelligence starts surpassing humanity's total intelligence. And then they literally just rewrite the universe from the inside by deriving mathematically a digital physics more consistent than the one created by the humans. And okay, I will come back to this. It will make sense. A lot of people out there, myself included, like, when you look at the thing you build, you can't help but think of it as a product, and then you see yourself as a gardener. You're supposed to make it beautiful. You take out the weeds when they come in. You're like, oh, I want to make sure that my systems on the blockchain is good for people, the right kind of people, and for businesses, the right kind of businesses. Don't worry about these silly smart contracts. We just use them to build the thing, but they're not the primary thing here. But the issue is, like, if you keep doing this, if you start as a gardener, you remove the weeds, you build a beautiful system, like still thinking that Ethereum is a financial computer, and then the bots come in, and you're like, okay, let's add some proof of humanity and rate limiting, and then more bots coming, and you're like, fuck, like, this is, like, one day your protocol or your world will see its Lambertians come in. What are you going to do to the Lambertians? Because you're not building a garden, you're building this, you're building the step. The step can't be good for anyone. It's not easy to get in the step. There is no like entry gate where you pay for your ticket and then they give you a lunch. Okay. This is funny enough. Even if multiplayer games today like masquerades as being universes, there are secretly just theme parks with entry and exit gates. So don't try to build this. Like, the hardware you have is not a hardware for theme park, it's a hardware for the step. You're building for the bugs. When the VCs asks you who your customers are, it's the bugs. What's the total addressable markets? The Lambertians are going to be fucking rich, guys. I don't know if they'll be happy to have an angry god. So that's probably why the Lambertians will live in worlds that are truly autonomous. But yeah, these are your customers. All right, back to the assembly. This is what's happening in the autonomous world community right now. There's a cycle of fucking around and a cycle of finding out. During most of the years, people argue and build stuff. And then the way we've been designing this assembly and also the publication, the book you received, is as almost like a compression step after the fucking around. You come here, you talk about your ideas in a way that is honest. You really explain, like, this is what I learned. This is why I fuck up here. This is where I screwed up. This is how I can learn better. And then we put it in the book, and then you go back to the arguing on Telegram, you build better stuff, and so forth. So the structure has been designed around this. You might have seen some weird words on your schedule, like pre-assembly, assembly, post-assembly. I will give a short explanation and a translation of what it means. So before that, here's a couple of things I will ask you to do. So first, Arthur insisted a lot to all the speakers to be intellectually honest. What this means is, like, we're here to learn, and we're here to find a narrative that makes it such that the computer is not going to be stuck where it is. In order to do that, we can't be here to sell stuff to each other, right? If you try to sell stuff to each other, you're not going to find what the computer is truly for. So be intellectually honest, explains where your stuff's like stop working, and learn from each other. Second, be slightly insane. If you can't like take 2 days to just say a bunch of crazy stuff, maybe you don't deserve the wizardry digital physics for autonomous worlds you're trying to create. It is important to to like let go of like suspend disbelief for a little bit. And finally, there are no spectators. Everybody here is expected to participate, not in like a homeworky kind of way. I actually think it's going to be fun. The third part of the assembly is a big unconference where you take all the learnings and all the questions you have and all the confusions, and you just argue for 5 hours in a row. It sounds hard, but it's really fun. We did it in 2 hours, 3 hours in a row. Okay, only 3 hours of arguing. You're lucky. So first part is this part is the pre-assembly. The pre-assembly is a marathon. We will sit in this room. I will look if anyone leaves. It's only to go to the bathroom. We will sit in this room for the next an hour and a half, and there will be 3 speakers after me, 3 very experienced, very thoughtful people that have kind of like built narratives and ideas and systems of thoughts parallel to this idea of autonomous work for a very long time. And I think that listening to them will open your mind for the second part, the assembly. So during the assembly will run in parallel. There is no main stage at the assembly. There is no like talk that is more important than another one. There will be multiple stages in parallel where people will do workshops and presentations and all of that. It will be very chaotic. That's the point. Go around, don't FOMO too much, and learn from what the people will say there. And the third part is the post-assembly. We will come back here tomorrow afternoon to go through an unconference session. At the end of each presentation during the assembly and some presentation during the pre-assembly, speakers will leave questions on the last slide of their presentation. These questions are prompts for what to talk about during the unconference. So my translation is, 1 is you expand your mind, 2, you share ideas, and 3, you compress and you find the next fuck around cycle from that. So finally, that's just what I added. It's like, that's just what I said. Basically, cool questions at the end of each presentation. Second, we have a private Reddit-like system, post-assembly.null.io. Open it on your computer. There's already a bunch of questions there. You can propose things to talk about during the unconference and upvote them, and then the organizers will sort these questions by upvotes and create tables where people can talk about these topics. And that's it for me. Thank you.